IMS Gate Academy. How are you all? So please do reply whether audio video both are clear or not. Just for the sake of convenience, whether all audio video are clear or not, just do let me know so that we are ready with this particular session. Okay. So yeah, again welcome you to the part 2 of the measurement, basically the gate score booster session. As you already know that we had already covered the part 1 on yesterday, and this will be the part 2 on. And in part 1 we had seen quite interesting question, isn't it? And in that we had covered 50% of the syllabus of the measurement, whether you are from EE and IN, including both we had covered. Okay, excellent. So we had covered both streams, and basically 50% of the syllabus we had already covered. So in this part we will going to cover the remaining 50% of EE and IN syllabus. Alright. So one request, guys, please do share the session link with your friends so that they can also join live as quickly as possible. Alright, so that we are going to have a wonderful and competitive session over here. Alright. And also do not forget to mark your attendance by hitting the like button, which is very, very important. I want to know how many of you are live here. Okay. Alright, so please do share the session link with a friend and the colleague, and definitely we will going to see some amazing question which you have never ever seen, not even in the gate exam you have never ever seen. Okay, so here basically whatever question I have come up with, those are the amalgamation of the different subject. Like in some question you will going to see the combination of 2 subjects question, or the combination of 2 chapters, and so on and so forth. Like so, such kind of question I have framed and I have come up in this particular session. So before going ahead, one request, please do ready with your pen and your rough copy or notebook, whatever you are having, because once I will going to show the question over the screen, I will give you some amount of time to solve those particular question. Okay, and once the time is going to be over, I will start the solution. So during that duration, means as soon as I have given you the timer, so once the timer is going to be ended up, whatever answer you are getting, please do comment in the chat box, so that I come to know that how many of you are right or how many of you are wrong. Please do not bother about even if you are getting the wrong answer. Here we are like basically we are here to learn. Okay, whatever mistake we are doing, here we are to rectify those. So please do not get worried about this. Okay, so please do learn from your mistake, whatever thing or mistake that you are doing, please learn from that and do not repeat in the original gate exam. Okay. Alright, so again please do share the session link, because I am seeing a very few students over here. Alright, so let us come with the chapter 5. Like as I told you, 4 chapter we had already completed yesterday, and this will be the chapter 5, which is the cathode ray oscilloscope. Again, it is one of the important chapter for EE and IN. And what are the important topics under this? YT plot and frequency measurement from XY plot. As you know that YT plot, like a CRO is basically a device which can operate in 2 mode, which is known as YT mode, or also known as sweep mode, and the another one is XY mode. In YT mode, we can see the unknown signal. Like see, the basic ammeter and voltmeter is what? We can measure only magnitude, like ammeter, voltmeter, that are conventional, which are analog. Like you are having an electrical circuit, and at particular resistance, if you want to measure the current, then we can only have the magnitude, not the waveform or the nature of the current. So if you want to observe the nature of the current, then for those particular reason, we require CRO, cathode ray oscilloscope, and the unknown signal is observed in YT plot. Alright. Now unknown signal will have the phase angle and frequency. So those phase angle and frequency is measured from XY mode. In XY mode, we can measure unknown frequency and unknown phase angle. Okay, so these are the basics related to the cathode ray oscilloscope, or in short CRO. So here comes the first question. Let me give you a time of 2 minutes. After that I will going to start the solution. The time starts now. So open loop system is given to us. This is CRO, or basically the Lissajous pattern you can say, and we need to find the omega x. What will be the value of omega x that we need to put up over here? So use the concept of the control system which you have studied in Routh-Hurwitz criteria, and from there you will going to get one parameter, and from that parameter we will be able to find this omega x. Any answer? $30 remaining, do it fast. Still I didn't get any answer, please do reply. $10 remaining. And the time is up. Alright. So a negative unity feedback control system with OLTF, open loop transfer function, as k upon s plus 1, s plus 2, s plus 3 is found to be marginally stable with frequency omega y. Two sinusoidal input are applied to y and x plates of CRO with frequency omega y and omega x respectively, and the following Lissajous figure are observed on the screen shown below. So this is your Lissajous figure, and the outer boundary is basically what? The boundary of the CRO. The value of omega x is dash radian per second rounded off to one decimal place. So from here, which is basically a Lissajous pattern. So Lissajous pattern is observed on XY mode. In XY mode, first known signal which is having the frequency omega x is applied, which is known as reference signal, reference signal, and through that reference signal will be able to identify the phase angle and unknown frequency of the unknown signal. So combination of known signal and unknown signal is giving us a Lissajous figure, and always remember, known signal is applied on x input, whereas unknown signal is applied on y input. So y input is on top side and your x input is on you can say at the left hand, at the right hand side. Okay, see, this is your screen, isn't it? This is your screen. So the top side will be applying the unknown signal, and from here, from the right side, will be applying the known signal. All right. So as in the question it is given that the system is marginally stable. Which system? Closed loop system. So let us frame the closed loop transfer function. Let us make the closed loop transfer function CLTF, which is equal to G of S upon 1 plus G of S for negative unity feedback system. Now your G of S is given as k upon s plus 1, s plus 2, s plus 3 whole divided by 1 plus G of S. So 1 plus k upon s plus 1, s plus 2, s plus 3. So on solving this, we will get the equation as k upon s plus 1 into s plus 2 into s plus 3 plus k in the denominator part. So, like multiply this term, we'll get s cubic plus 6s square plus 11s plus 6 plus k. Done. And the denominator part of the CLTF is known as characteristic equation, which will decide the stability of the system. Done. So, the characteristic equation here is s cubic plus 6s square plus 11s plus 6 plus k. Alright. Now, in the question it was given that the system is marginally stable. What do you mean by marginally stable? Anyone? What do you mean by marginally stable? What do you mean by marginally stable? If a pole or if a roots of characteristic equation is purely imaginary, with non-repeated root, and remaining roots are on left hand side of S plane, then the system is said to be, a system here it means closed loop system, then the system is said to be marginally stable. Okay. Now here I will not going to use the RH criteria, rather I will going to use the shortcut. And what is that? See, whenever you are having the third order system, third order means, see here highest power is what? 3. So it is a third order characteristic equation, and if the sign or the coefficient of all the terms are positive or negative with no missing term, then we can directly apply the shortcut. See, for the shortcut, let me use different color. Okay. See, if the characteristic equation we are having as cubic plus bs square plus cs plus d, then b into c, like take the coefficient b into c, like first possibility b into c minus a into d, which is extreme and or external, internal product minus external product. If it is greater than 0, then the closed loop system is stable. Second, let me write 1. Second, if b into c minus a into d, if it is equal to 0, then it is said to be marginally stable. And third one, if b into c minus a into d, if it is less than 0, then the system is said to be unstable. Alright. So, as in the question it was given that the system is marginally stable. So, which case is satisfied? Case 2. So, here I am using the shortcut, and please remember, while applying the shortcut there should not be any missing term. It has to be third order with the coefficient all have the same sign. If any of the condition is violated, then the shortcut is not applicable. Got the point? Alright. So, here internal is what? Let me add a page. So, here 6 into 11 b into c, 6 into 11 minus a into d. So, a coefficient is 1 and d is 6 plus k. 6 plus k. This is equal to 0. So, once you make the system to be marginally stable, then your k is known as k marginal. K marginal. So, which is equal to 66 minus 6 is 60. So, if you choose k value here, k value as 60, then the system is going to be marginally stable. Pragyavat, great sir. Okay, thank you for such kind of work, Pragya. So yeah, so this is the value of k. If you put, the system becomes marginally stable. Now, once the system is going to be marginally stable, then as I told you, the roots are going to lie on the imaginary axis. Then how we can find that roots? The roots will be given by auxiliary equation. So here auxiliary equation will be taken directly, second term and last term. So this is shortcut, na? Auxiliary equation. Second term is 6s square plus 6 plus k. So k here is k marginal. Done. So this is your auxiliary equation. Now when you equate it to 0, we'll get the root of s. Like see, 6s square plus 6 plus what is k marginal? 60. Equate it to 0. So from here s square is minus 66 by 6 is minus 11. What is s? Sorry, here s is plus minus j root over 11. And what is s? S is plus minus j omega n, which is plus minus j root over 11. Now someone say that, sir, s is sigma plus j omega, na? S is sigma plus j omega. But my dear friend, as I told you, the roots are on imaginary axis. It means that its real part is 0. So we are left with only omega. So this omega is known as natural frequency or undamped frequency. So whenever system is marginally stable, the frequency that we are going to get is known as natural frequency or undamped frequency. This you had already studied in the time domain analysis, remember? So ये वही value है. All right. So we have we got the value of omega n as root over 11, which is radian in radian per second. But my dear friend, this omega n is nothing but your omega y. It is found to be marginally stable with the frequency omega y. So this is your omega y frequency. Done? All right. So the first part we had discussed. Now come to the CRO. So as I told you, this figure is going to obtain from the reference signal having the frequency omega x and the unknown signal having the frequency omega y. So from here we will going to obtain the omega x. See how. Okay. So there is a method which is known as intersection method to obtain the unknown frequency or to obtain the frequency. Like see, intersect the Lissajous figure in horizontal in vertical direction like this. Also intersect in horizontal direction. But the catch is, do not intersect via pre-existing intersection. What do you mean by this? See, this is what pre-existing intersection. So never draw a line which passes through this pre-existing intersection. Got the point? Otherwise your answer is going to be wrong. So the vertical cuts, how many cuts we are having? 1 cut, 2 cut, let me rub this, 3 cut, please do not count this, okay. 1 cut, 2 cut, 3rd cut and 4th cut. So vertical cuts is equal to 4. Now count the horizontal cuts. 1, 2, 3, 4, 5, 6. So your horizontal cuts are 6. Now we know the formula Fy by Fx is equal to unknown frequency divided by known frequency is equal to horizontal cuts divided by vertical cuts. Horizontal cuts divided by vertical cuts. Now Fy, it can be written like multiply by 2 pi and 2 pi, numerator and denominator multiply with a factor of 2 pi. Then it becomes omega y by omega x, which is equal to horizontal cut is 6, vertical cut is 4. What is omega y value? It was root over 11 divided by omega x, 6 by 4. So from here omega x is equal to 4 by 6 root over 11, which is 2.2 radian per second. So this will be the value of reference signal or omega x for which you are going to get such kind of Lissajous figure. Alright. So the correct answer for this question is 2.2. Any doubt? Any doubt till this point? Done? Okay. So let me take a few minutes to discuss on our courses. So this is live online program for GATE 25 and 26 student, and where we are offering 800 plus hours of live classes with the live interaction. So here you will going to interact virtually with the faculties, and whatever doubt you are having, you can like the technical doubt, you can ask in the live session itself. Next, we are providing the theory book, exercise book and 30 plus year GATE question bank along with video solution. So here we are providing the theory book of every subject along with exercise book. So exercise book are framed in a level 1, level 2, level 3, where level 1 is easy question, level 2 is moderate, and level 3 is highly difficult or conceptual, highly conceptual. So it is recommended that the student first solve the level 1, then go to level 2 and then attempt the level 3. So our expert faculties has designed a lot of question, and in that you will going to get a lot of problem from for the respective subjects. Alright, and 30 plus years of GATE question bank along with video solution. So whatever doubt, like even if you are not able to understand by seeing the solution, then you can visit to the video solution to get it clarified in more crystal clear manner. Next, 12 personalized one-to-one mentorship session, which is a USP of the IMS GATE Academy, where student and faculty are going to interact one-to-one, and whatever doubts students are having in terms of their strategy, in terms of the planning, in terms of timetable and so on and so forth, whatever doubt they are having, they can directly ask to the faculty, and our expert faculty will definitely going to help you out. And the last one is 130 plus online test with video solution of mock test and many more. So if you want to counsel yourself, then you can book a free counseling by calling on this number, or else you can click on the link which is given on the description box. So once you're going to fill the form, our counseling team will definitely going to help you out. Alright, so this is how our interface looks like. So the PDF of this lecture or all the lectures that we are conducting over the YouTube, you will directly find over the Telegram channel. Alright, so the link you will find in the description, or you can directly visit to this ID. And what we are providing in the Telegram at free of cost, we are providing schedule of free YT lectures, lectures PDF, as I told you, important update related to the seminar and webinar, PSUs and other government job notification, expert session on important topics, and daily quizzes and many more. So here most of the students or all the students are getting benefited by our daily quizzes. So please do join our Telegram channel. Definitely you will going to have a great experience once you're going to join. Alright, and as I told you, once this session is going to be over, the PDF you will find in our Telegram group. Alright, so let us move on to the next problem. So this is the next question, which is question number 2 for the today's session, and yeah, it seems to be quite difficult, challenging. So because of that, I'm going to give you some extra time. So let me give you 3 minutes of time, not more than that. So your time starts now. Do it fast. This question is a combination of your analog measurement both. Do it fast. Any answer? Last 10 seconds. Any answer? Any guesses? Any guesses? Okay, time's up. For the given circuit, the voltage waveform displayed on the CRO across the resistor R equal to 10 kilo ohm present in the branch AB will be. Consider ideal op-amp and ideal voltmeter. So if you see or if you observe the diagram very carefully or circuit diagram very carefully, you will find one op-amp and one you will going to find the bridge circuit. In the bridge circuit, we will be having the Jenner diode. This is your Jenner diode, not the normal diode. Okay, and you are having one resistor, and across that resistor we are having one meter. Okay, so what voltage that measure, or basically meter in the sense CRO here. So what voltage or waveform this CRO is going to display, that we need to find. Now here, do we have any input for this bridge? Yes, the input is given but indirectly, and that input is coming from this first element. Let me take this as first element, this is second element. Okay, and if you see carefully, this first element, just a second, this first element is your, कहाँ पे देखा है इसको? Analog. This you have already seen in the analog. So which is a stable multi-vibrator. Let me change the color, just a second. This is a stable multi-vibrator. Okay, so as I told you, this is a combination of your analog and measurement. Alright, so what we will going to do? First we will going to analyze part by part. First we will discuss about this unstable multi-vibrator. From here we will find the output, and in the second part we will discuss about the Jenner diode operation, and at the last we will going to find the waveform of it, V0. Alright, so let us discuss about the unstable multi-vibrator. Okay, so meanwhile let me draw the circuit. Okay, those who are solving, please do solve. Meanwhile let me draw the circuit. Minus plus, this is plus 10 volt, minus 10 volt, this is supply, and we are having the feedback like this. Okay, so this is 5 kilo ohm, this is 5 kilo ohm. Let me take the output as V01, output as V01. Alright, so where is the remaining part? And here at the negative terminal we are having one capacitor and one resistor. So we are having one capacitor like this, which is again grounded, 1 microfarad, and one resistor. Which is 1 kilo ohm. Let me check. 1 kilo ohm. Done. All right. Now, this unstable multi-vibrator is basically what? The output of this circuit is fixed. means at some interval of time output will be plus V set or plus saturation voltage, and at the second half the output will be negative saturation voltage. And from where we can find saturation voltage? Maximum voltage here, which is supply voltage, is known as your saturation voltage. So for the first half cycle the output will be plus 10 volt, and for the second half cycle your output will be minus 10 volt. And this output voltage cannot be controlled by us. This output voltage cannot be controlled by us. It means that we cannot control the output, therefore it is known as a stable multi-vibrator. If it is if the output is controlled, then it is said to be monostable, like that, multi-stable, so on and so forth, because we can control the output. But here we cannot be able to control, therefore it is astable, or in some case in layman term we can say that unstable. Okay, all right. So let us take the capacitor output as, sorry, the capacitor voltage as Vc of t, and here this voltage is plus minus, let me take Vx, plus minus Vx. Now please listen me very carefully. Here V01, which is the output of this op-amp. So what is this? Equals V01 is equal to gain of this op-amp, which is open loop, into voltage at positive terminal minus voltage at negative terminal. This is what your output. Now let us take, for the simplicity, AOL to be 1. Like ideally it will be very, very high, but it is not our what to say, our statement or our solution part is not even going to affect if you take AOL as 1. So for simplicity, let me take AOL as 1. So therefore your V01 will be equal to V plus minus of V minus, means positive terminal voltage minus negative terminal voltage will give you V01. So what is the positive terminal voltage? It is Vx. See, this voltage is Vx, na? And this voltage is coming at positive terminal, so it is Vx. And what voltage at negative terminal? It is capacitor voltage, Vc of t. So what is Vx, my friend? Sorry, Vx, apply voltage division rule. Total output is, sorry, the total supply here is V01 across 5 kilo ohm. Our output will be 5K upon total 10K into V01. So let me take this value as beta, this value as beta. So beta V01. And as I told you, V minus is Vc of t. So V01 from here, V01 from here I can say it will be equal to beta V01 minus Vc of t. Now how your output is going to be plus V set and minus V set? It depends on your capacitor voltage. Like how fast your capacitor is charging or how fast your capacitor is discharging. If you see carefully, your V0 is going to have either plus 10 volt or minus 10 volt. So depending on this, your capacitor is going to be charged in one direction, and in another half cycle it will going to discharge like this. Done? Okay. So see, whenever beta V01, see here, whenever beta V01 is greater than Vc of t, then your output V01 will be equal to plus V set, which is equal to plus 10 volt in our case. Okay, plus 10 volt in our case. So from here I can say that, look at here, from here I can say that your output is going to, your output is going to, let me take here plus beta V set and this is plus V set. So from here I can say that whenever your capacitor is charging and it is less than beta V naught 1, then your output is equal to plus 10 volt, plus 10 volt. Got the point? So here capacitor, let us say it is charging. So look at the diagram. Let me change the color over here. So okay, meanwhile let me write here, this is minus, sorry. Let me mark the reference point. This is minus beta V set and here it is minus V set. Okay. Now please listen me very carefully. I am going to discuss very important point. Now your capacitor is going to be charged like this, and it goes to till plus beta V set. So till this point your output will be, V naught, sorry, your output will be V set, as I told you. Now what if the capacitor, this is a capacitor charging equation, this is Vc of t. Now what if the capacitor is going to cross this beta V set? Now look at here. As soon as Vc of t is greater than beta V naught 1. So here V naught 1 is plus V set. So let me write here V set. Like from here, which is case 1 basically. So V naught 1 was V set. So put here V set. So whenever, as soon as your Vc of t becomes greater than beta V set, means it is going to exceed the beta V set, then my dear friend, from this equation, कहाँ गया V naught 1 वाला, what it going to be? It going to be negative. Earlier it was positive. देखो यहाँ पे V naught 1 यहाँ पे क्या है? Greater than 0, which is positive. Therefore your V naught 1 was plus V set. But this time V naught 1 is less than 0 because here this is greater compared to this. So therefore your V naught 1 becomes minus V set. So your output equation now becomes minus beta V set minus Vc of t. हाँ, यहाँ पे. Okay, when V naught 1 becomes minus V set, so substitute minus V set here. So this will be your equation. Okay, so yeah. तो वो कैसे होगा? See, let me change the color. See, means here it will going to discharge like this. Like this, and at this point your output, like from here, once your capacitor is going to exceed, it will going to transit from plus V set to everybody, plus V set to, which color should we take? This one, sorry. Plus V set to minus V set. This is what we had discussed, na? Plus V set to minus V set. Done? Okay. Now, as soon as, look at here. Vc of t becomes more less than minus beta V set, more less than minus beta V set. तो क्या होगा V नॉट वन? V नॉट वन इट मीन्स माइनस बीटा V set माइनस वी सी ऑफ टी. हाँ, ये क्या होगा? इट विल बी ग्रेटर देन जीरो. भैया ये नेगेटिव, ये मोर नेगेटिव होगा इससे ना. लेट अस से इफ दिस इज -10 और लेट मी टेक एन एग्जांपल, इफ दिस इज -2, व्हाट डू मीन बाय लेस देन -2? -3, -4, -6, so on so forth like that. So it makes this difference to be positive. So this implies V01 now again switch to plus V set, and the process is going to repeat, and the process is going to repeat. Okay, so as soon as it is going to be more negative, then your output is going to, then your output is again going to switch from minus V set to, sorry, from minus V set to plus V set, like this. Done? And from here onwards, the capacitor is again going to charge like this. Like this, and it will be plus V set till the capacitor charges to, or it reaches to plus beta V set. So the process is going to get repeated like this. Any doubt? Any doubt? And if you see carefully, this time period which is t, this time period which is t, and the duration of charging and discharging are half of the total time. So this is t by 2, this is t by 2. So that is what I was told you, that the charging and discharging is not in our hand, it is fixed. So it is charging for fixed time, and again it will discharge for the fixed time. So what is this total time period t? So I am skipping the derivation part. So t is 2 RC natural log 1 plus beta upon 1 minus beta. So like in some of the subject you may going to use this expression, but in our case this t is not at all required. But anyway, for the sake of convenience, I have written. And what about this? This is t by 2. And this is t by 2. Again this is t by 2, means charging and discharging is going to be repeated like this. Okay, so this is all about the output, okay, output of the astable multivibrator, and we see that it is equal to plus 10 volt and minus 10 volt. Now we have got the input for the bridges. Next, let us discuss about the Zener diode, the second portion of the problem, okay, of the problem. I am talking about this one, because your output depends on this basically the region of operation of this Zener diode. So what is Zener diode? It is a voltage regulator, means once a certain condition is reached, the voltage of the particular diode will be fixed. So here what is that voltage? 8.3, and Zener diode is basically going to operate in 3 regions. First region is forward bias, second region is reverse bias, and third region is avalanche breakdown region. Okay, so this is unlike to your normal diode. Okay, so let me make the diagram here. The Zener diode. this is anode, this is your cathode, and diode will have the cut-in voltage as, means in the reverse direction, the cut-in voltage as Vz, and let us take the voltage across this diode is V2, means Vd. All right. Now, as I told you, this is going to operate in 3 regions. So, let me mark the axis here. Okay. So, see, this is Vd, this is Id, means voltage across this diode and current through this diode, let me take Id, or in some case it is Iz. All right. Now, if Vd is positive, or if the current direction Id or Iz is following your diode direction, then it is said to be in a forward bias region. So, when Vd is positive, then Zener diode will operate as an forward biased region. Forward biased. So, in forward biased, Zener diode behaves as short circuit. Got the point? It means like this. So, it is shorted. Next, in the left hand side region, you will be having one voltage which is Vz. So, from here you come to know that Vz value will be negative. Now, if your voltage is from 0 volt to till Vz, like here Vz is not included. If your voltage is from 0 to till Vz, where Vz is not included, then your Zener diode is said to be operate on reverse bias region. So, here it will be reversed bias. It means that Zener diode behaves as open circuit. It means that it will be like this. All right. So, the reverse bias condition is achieved in 2 manner. Either this Vd becomes negative or current direction is reverse to the shown direction. Means अगर ये ऐसे आ रहा होगा या फिर Vd negative हो. So, in both the cases, it will be said to be in reverse bias if Vz is not exceeded. All right. Now, as soon as this voltage is going to increase in the negative direction, suppose you have reached to Vz, then your Zener diode is said to be enter into avalanche breakdown. So, in avalanche breakdown, what is going to be happen in avalanche breakdown? Your current is going to be increased drastically, but at the same time your voltage is going to be fixed. ठीक है, वोल्टेज फिक्स हो जाएगा बट करंट जो है वो रिवर्स डायरेक्शन में बढ़ते जाएगा. दिस इज व्हाट नोन एज वोल्टेज रेगुलेटर. मीन्स द जेनर डायोड इज ऑल्सो नोन एज कांस्टेंट वोल्टेज डिवाइस. All right. So, here it is said to be enter into the avalanche breakdown region. Avalanche breakdown region. So, here Zener diode voltage Vd now fixed to Vz. I hope this is clear to you. So, here just a second, let me shift this to upward. So, we can represent this like to be a voltage source. Any doubt till this point? Any doubt? Clear है? Tick? Okay. So this is what we have discussed about the general diode. Now we need to identify in which region our general diode is going to be operate for the given circuit. So because if it is short circuit, output voltage will be different. If it is open circuit, output voltage will be different. If this is a constant voltage device, then output voltage will be different. So that depends on this Vz value, and in our question Vz was given as 8.3 volt. 8.3 volt. So let us find. Okay. So here first case 1, when output is positive. Case 1, when V01 is plus Vset, which is plus 10 volt. Okay. So your circuit will look like this. So this is plus 10 volt. Now my task is to find whether this diode is open or short. So for that we need to find the voltage here. If the voltage is more negative than 8.3, like if the voltage is, suppose we are getting, we would be getting as -9, then it will behave as a constant voltage device. If the voltage, let us say if it is coming out to be as 7, then it will be taken as a open circuit. If the voltage is coming out to be positive, then it will behave as a short one. So for that we will assume, let us assume Zener diode is operating in reversed bias. This implies Zener diode will be open circuit. Okay. So let me make the diagram for the clear understanding. So this is 10 volt. So this is 10K. Those who are solving, please do solve and let me know the answer. This is 10K. This is resistance R, which is 10K, and this is here we are having the voltage as plus minus V0. Let me write plus minus V0, and after this we are having one more resistance like this, and as I told you, we will consider this to be open circuit, and your circuit is going to be closed like this. Okay, done. So this is 10K, and this is also 10K, which is R and plus minus V0, and we have kept this Zener diode to be open. So let us assume the voltage here as plus minus Vz. Okay. So let us take some certain parameter which helps us to find this Vz value. Sorry, this is total current I. Here let us take I1. Let us take this as I2. So since this is open, this current will come here again as I2, and total current here is I1 plus I2 is again I, which is this current. Now first let us find total current I. Total current I. Now if you see carefully, these two are in series, 10K and 10K. and this 10K in series becomes 20K. This 20K is now in parallel to this 10K, and after that the combination is in series. So I can directly write I as, I hope you are getting this, as 10, see this 10 plus 10 20K parallel with this 10K and combination are in series with plus 10K. Alright, so this value is coming out to be, let me check, this value is coming out to be as 0.6 milliampere. Everybody please do check, 0.6 milliampere. Done. Now let us find I2, because from here we'll get Vz. Find I2. Now I can directly apply the current division rule. So see, I2 will be equal to total current I into opposite by sum. Opposite resistance is 10K divided by total sum of the resistance, 10K plus 10K plus 10K, which is 30K. So I is 0.6. So 0.6 by 3, 0.2 milliampere. I hope this is clear. कोई doubt है यहाँ पे तो please मुझे बता दो एक बार. If you are having any doubt, please do let me know. Now apply KVL in this loop. Apply KVL in this loop to get this plus Vz. So see, this is minus 10K into I. Minus 10K into I plus minus I2 into 10K, minus I2 into 10K, then minus Vz, minus Vz. What I did, see, I am going in this direction, my loop direction is this, whereas the current direction is opposite to my loop direction. Therefore, I have taken negative sign while finding this voltage drop. And whatever terminal or the polarity, not the terminal, whatever polarity comes first, I will take that sign. So here, while traveling in this loop, negative sign comes first, like this. So I will write here minus Vz. So from here, minus Vz or Vz is equal to, look at here, Vz is equal to minus 10K into I is 0.6 milliampere, then minus I2 is 0.2 milli into 10K. So this is equal to minus 8 volt. And as I told you, this Jenner diode is operate on reverse bias region or for the negative voltage. So for the negative voltage, anyway it is written as 8.3, but it is actually minus 8.3 because we know that it operates in negative voltage. It operates for negative voltage. So it is minus 8.3. Now if you see carefully, this is minus 8.3 and we are getting the voltage as minus 8. So therefore our voltage, therefore our Jenner diode is on reversed bias region. So our assumption is correct. So let me write here, since cut-in voltage for Jenner diode is minus 8.3 volt, which is more negative, than minus 8 volt. Therefore, Jenner diode is reversed biased. Okay. So our assumption is correct. So our assumption is correct. All right. Now my task is to find this output voltage now. What is this output voltage? Look at here. What is this output voltage? V0. Can I say it is minus I2 into 10K. So this implies V naught is minus I2 into 10K, which is R. This is R. So I2 is 0.2, so therefore minus 0.2 milli into 10K, which is equal to minus 2 volt. So yes, for the positive half cycle, basically means case 1, extremely sorry, this is case 1. So for the case 1 or for the first half period, we have obtained the voltage here as minus 2 volt. Minus 2 volt. Now come to the case 2. When V naught 1 is minus V set or minus 10 volt, means the rest half. So here this circuit, sorry, it will be like this. Okay, minus 10 means, look at here, minus 10 means it will be like this. Here we have taken V naught 1 na, so this is minus 10. Done? Or else you can what to say, you can replace this equivalent thing to like this. Both are same, here both are same. Done. All right. Now if you see carefully, this is your source and from here the current will leave. From the positive terminal the current will leave. Done. And after coming here the current is going to be divided into two parts. One will go here and one will go here. Now since the current direction and your diode direction both are same, therefore in second half cycle your Zener diode is going to operate in forward bias region. Got the point? How to identify the reverse bias, avalanche breakdown and forward bias? Since current direction is same as that of diode, means Zener diode direction, therefore Zener diode behaves as short circuit. Done. All right. Now let me draw the diagram. As I told you, either you draw this kind of polarity or you can reverse this by taking this as minus 10 volt. Both are same. Okay. So what we have here, we are having 10K, then again 10K, here again 10K, this is 10K and this is shorted. As I told you, this is shorted. All right, and this is plus minus V naught for the remaining half. All right. Now if you see carefully, this point and this point are at same potential, or since this is shorted, I can directly take this point to be till here. I can directly take this point to be here. So मैं इसको इस तरीके से बना सकता हूँ इस डायग्राम को. Look at here. दिस वॉज 10K, इसकी बात कर रहा हूं मैं. And this is shorted like this. Anybody having any doubt in understanding, please do let me know. I will rectify your all doubts. Okay, so my task is to calculate this voltage V naught for the remaining half. So let me take the current here as I, let me take this as I1, let me take this as I2, this as I1 dash, this as I2, sorry, I1 double dash. All right, so to find this V naught, I require I1 dash. To find I1 dash, I require I1, and to find I1, I require this I. So let us first find I value. So this is equal to minus 10. Total voltage is minus 10. Now please listen me very carefully. This is in parallel combination. 10K, 10K becomes 5K. 5K is in series with 10K, so 15K, and this 15K is in parallel with 10K. So 10K parallel with 10K. Now this will be in series with 10K. Now this all together is in parallel with this 10K. Okay. So on solving this, we will be getting the answer as minus 1.67 milliampere, minus 1.67 milliampere. Now let us find this I1 value. How to find this I1? I1 is total current, which is I, into opposite. So here opposite will be what? 10K divided by sum. Okay. So the parallel combination of this is 5 plus 10, 15, 15 plus 10, 25. Means 10K plus 5K plus now this 10K. So on solving this, we'll get the I1 value. If you are having I1 value, please do let me know. I'm not having. Okay, let me calculate. I had got as minus 1.67. Just a second. Minus 1.67 into 10 divided by 25, I guess. 10 plus 10, 20 plus 5, 25. So I'm getting this as minus 0.668 milliampere. Done. So we have got I1 value. Now let us find I1 dash. So I1 dash is equal to I1 into opposite by sum. Opposite is 10K divided by sum, which is 20K. हाँ, इन दोनों का sum. हाँ, तो कितना आ रहा है? So answer divided by 2. So I'm getting this as minus 0.33 milliamps. Minus 0.33 milliamps. Okay. So we have got I1 dash value. Now from here, what is V naught? Sorry, V naught. V naught is, look at here. My current direction and the polarity both are same. So it will be I1 dash into 10K. I1 dash into 10K. I1 dash is minus 0.33 into 10K. So this will be minus 3.3 volt. Minus 3.3 volt. Or else this will be minus 0.3334 milliampere. So you can write minus 3.33 volt. So for the first half cycle, look at here. Okay. So for the first half cycle, my voltage is minus 2 volt, and for the remaining half cycle it will be minus 3.3 volt. So this is first half cycle, which is T by 2, remember, T by 2, and this is other half cycle, which is means the remaining half cycle, which is T. So overall this is T, and we had already seen the formula. 2 RC natural log 1 plus beta upon 1 minus beta. So, during this half it will be minus 2 volt, and after this it will transit from minus 2 volt to minus 3.3. So, from here onward it will be minus 3.3 volt. Okay, so after this it will going to get repeated like this. Any doubt till this point? So, in which option we are getting this figure? Okay, where it is? T1 is basically T by 2. So, minus 2 volt, okay, and minus 3.3. Only in option B we are getting the same figure. So, option B is the correct option for this question. Okay. So, कैसा लगा question? Did you find it a difficult one, conceptual, more tricky? So, please do reply in the chat box. Alright, so this is about the question number 2, I guess. Let us move on to the next question that we have in the measurement, which is again from CRO. Again from CRO. The following Lissajous pattern was observed on CRO screen as shown beside for the two input signal Vx of t and Vy of t given to x and y plates of CRO. Sensitivity Sx equal to 1 division per volt and Sy equal to 1 division per volt, means here the sensitivity both are same. If both the inputs are applied to the circuit given below, then the output voltage V naught is dash volt rounded off to 1 decimal place. Consider diode and op-amp as ideal one. Alright, so this is your CRO screen, and in the CRO screen we are obtaining this as a Lissajous pattern, which is a straight line. Now my task is to calculate V naught value if I have Vx of t and Vy of t. And what is this Vx of t? This is the input applied on the CRO at X plate, and Vyt is the input which is unknown input applied on the Y plate of the CRO. So my task is to calculate first this Vx and Vy. Now how I am going to get? I am going to get this thing from this CRO diagram. Okay. Alright. Now look at here. Suppose if the diagram would have been like this, if the diagram would have been like this, means these are the boundary of the CRO and this is a diagonal straight line which is passing through the origin. Here you are having some shift in the y direction, but as of now please forget this one. Come here and assume that you are having this kind of figure which is a diagonal straight line passing through the origin. Then in this case your Vx of t is Vm sin omega t and Vy of t is Vm sin omega t. Vm sin omega t. Okay, means here the unknown phase signal, like it has to be actually like this, omega yt plus phi. Now for the Lissajous pattern, please listen very carefully. For the Lissajous pattern, whenever you are seeing the Lissajous pattern, then there is one condition: omega x has to be equal to omega y. Means let me take omega. This is the first condition. Done, and your input maximum value, basically Vm, has to be equal as well. Means Vm Let me take here Vmx, Vmy. So Vmx, Vmy is equal to Vm. So this two condition we will have to pre-assume. Done. All right. So what it makes, Vx of t equal to Vm sine omega t. So this is my reference signal. I am applying this signal. So this is a reference signal. Which is generated by the signal generator, which is by me or by us or by the consumer. Now, and Vy of t is again equal to Vm sine omega t. What about phi? When phi is 0 degree, then you will going to get this Lissajous figure. This Lissajous figure. You just a second. Then you are going to get this Lissajous figure, means phi is 0 degree. So let me take here like this. So this is your unknown signal. Now if you see carefully, your signal is jumped by 2 division. Your signal is jumped by 2 division. Since we cannot change anything in the reference signal, so this shift has been done, or because of this Vy of t, because we cannot change anything in Vy of t. So whatever shift you are getting, that is because of your Vy of t. And what are the shift? What are the shift? 2 division. And we know that for 1 division we are having like for 1 volt we are having 1 division. Then for 2 volt, how many division? 2 division. So how many division we are having? 1 and 2. So here basically what we need to do? What we need to do? Shift this by 2 division like this. So your Vy of t will be 2 plus Vm is again 2. Vm is again 2 sine omega t. And what about Vx of t? It will be same, means 2 sine omega t. This is how we will be getting the Vx and Vy. Any doubt? Till this point, any doubt? Clear? Now, we have got Vx as 2 sine omega t and Vy as 2 plus 2 sine omega t. Okay. Now, this is your op-amp and I need to find this voltage V0. This voltage V0. यही फाइंड करना था क्या? अच्छा नहीं, ये वोल्टेज की बात करें. So let me take V01. V0. The output of the first op-amp. V01. This output. Output of the first op-amp. So कैसे फाइंड करेंगे? Look at here. So first find the output or the voltage, not the output, voltage here. So ये voltage कितना होगा? See, as I told you, your op-amp is ideal. It means that no current is going to enter into the op-amp. So this current, let me change the color. So here the current is 0 ampere. Again the current here is 0 ampere. So let me take this voltage as plus minus V dash. So what is V dash, my friend? What is V dash? V dash. So your V dash is equal to total voltage, which is 2 sine omega t, which is of Vx. And since no current is entering here, so whole current will pass here. So we can directly apply the voltage division rule. So V2 into sine omega t into R upon total resistance, which is R plus R. So we are getting this as sine omega t, I guess. यही मिल रहा है ना? Everybody please do check. Sine omega t. Now we know that from the op-amp basics, the non-inverting terminal voltage will be equal to negative terminal voltage, which is here. So the voltage Vx or V dash, which is the voltage at the positive terminal. Due to ideal op amp, this is also equal to the negative terminal voltage V minus here. Okay, here. Done. Now apply KCL at this node. At this node. Node क्या ले ले? Node जल्दी बताओ क्या ले ले? Node P. Node P. ये कलर विजिबल है ना? नहीं है? Okay. Apply KCL at node P. Let us see what we are getting. V minus at P, what is the voltage? V minus Vy of t whole divided by resistance, which is R, plus V minus V naught whole divided by R, this resistance, plus 0, this value, the current here, because we are having the three current. Now one will be in this direction, one is here, and one is entering into the op amp, which is 0 ampere, equated to 0. जरा देखो तो क्या आ रहा है? It will be V minus, so total 2 V minus Vy of t, which is equal to V naught. So V naught is equal to 2. V minus is what? Sin omega t, है ना? Sin omega t minus Vy of t. Vy of t is 2 plus 2 sin omega t. It means that minus 2 sin omega t. So this is equal to minus 2 volt. This is equal to V naught 1. Extremely sorry, V naught 1. So we have got the output of the first op amp, which is V naught 1 here, as minus 2 volt. So this will act as an input for the next op amp. So this is your next op amp. So this is V naught 1, which is minus 2 volt. Okay, this is what? A negative, this is a inverting op amp. Inverting op amp means if the input is positive, then output will be negative. If the input is negative, then output will be positive. This is what a negative terminal means, or negative op amp means. So here let us take the output as V naught dash. Now see, since given op amp is inverting, therefore V naught dash will be positive as input is negative, ठीक है? So look at here. Let me change the color. Okay. So here, since V naught 1 is negative, so it will be positive. Now here you will be having the two diode. Let us take this as diode 1 and this as diode 2. So since this is positive, V naught dash is positive, plus will come here, minus will come here, plus will come here, and minus will come here. And from the basics of the diode, if the polarity is reversed to that of the anode and cathode, then it will act as a open circuit, and if both are same, then it will act as a short circuit. So diode D1, let me take this as D1 and this as D2. This implies D1 is reverse biased, means it gets open, and D2 is forward biased and it will behave as a short or short circuit. ठीक है? So your equivalent figure, let me draw somewhere here. This is R, this is V01, okay, minus plus is grounded, then I guess this was 5R, na? Yeah, this was 5R and this is V0 and D1 is open whereas D2 is shorted. Okay, whereas D2 is shorted. This is how the circuit will look like. Now this is not simply your negative inverting, or basically the inverting op amp, not the negative. It is a inverting op amp. For the inverting op amp, we can directly write the output and input relation. Let me change the color. V0 by V01 is equal to minus 5R by R. Or else you can apply KCL at this node. Considering the op amp to be ideal, you will going to get the same result. Done? Now V0 is equal to minus 5 times of V01. And what is V01? V01 is minus 2 volt. Somewhere we have obtained, yeah, minus 2 volt. So this is minus 5 into minus 2, which is equal to plus 10 volt. Okay. So we have got our answer, which is plus 10 volt, which is going to be wrong. Which is going to be wrong. Why, sir? The reason is, if you see, the supply voltage of this op amp is what? Plus 8 volt and minus 8 volt. Therefore, you have fixed the maximum voltage of the op amp. Op amp cannot be exceed this plus 8 volt or minus 8 volt. Got the point? But what you have got? You have got plus 10 volt. It means that it is a wrong answer because op amp cannot exceed the plus 8 volt. So therefore, in that case, since saturation voltage is plus minus 8 volt, therefore V0 is equal to plus 8 volt. Done? Why not minus 8 volt? Because it is a inverting op amp. So input is negative, therefore output has to be positive. So plus 8 volt. So correct answer for this question is plus 8 volt. Any doubt? So I hope this question is clear to you. Let us move on to the next problem, which is here. For the two sinusoidal signals whose frequencies are Fy and Fx respectively, the following Lissajous pattern was obtained on CRO screen as shown below. So this is your Lissajous pattern where the outer layer is the boundary of the CRO screen. The value of the N for the cascaded counter shown below is, so we need to obtain the N value such that my input frequency becomes 50 hertz. So let me give you 1 minute time for this. Do it fast. Okay, time's up. Alright, so first let us find the Fy value from the Lissajous pattern. So we will be using the same thing, intersection, okay, horizontal intersection or the horizontal cut and vertical cuts. So this is horizontal cut and this one is your vertical cut. So horizontal cuts is equal to 1, 2, 3 and 4, and vertical cuts are equal to 1 and 2. Again, please remember, do not intersect via pre-existing intersection like this. It is going to be wrong. Okay. Now we know the formula Fy by Fx is equal to horizontal cuts divided by vertical cuts. So horizontal cuts is 4 divided by 2. Fy is unknown, but Fx is 500 hertz, na? 500 hertz. So this is equal to 4 by 2 means 2. So Fy, we got this as 1000 hertz or 1 kilohertz. So we have got this Fy value, which is the output of the 5-bit ripple counter. Now since your input for this mode N counter as 3.072 megahertz, which will going to give you the output Fy as 1000 hertz, so what should be the N value? So for that we will going to do the part by part analysis. So let us take this input as F, this input as F. Then the output frequency of mode N counter, let me take F1. Then this F1 will act as an input for 4-bit Johnson counter, and let us take the output for 4-bit Johnson counter as F2. I hope this color is visible. Okay, and the output of 5-bit ripple counter is Fy, which is this is given as 1000 hertz. That is what we have got. Okay, so look at here, for mode N counter, your output F1 will be equal to F input frequency divided by N value, this value. Done. Now for 4-bit Johnson counter, or let me take for simplicity this to be N or this to be M. Better to take M. Then for M-bit Johnson counter, your input is F1, output is F2. So in this case, your F2 will be equal to F1 upon 2M. This is for M-bit Johnson counter, and this is for mode M counter, mode N counter. Done. And for the last 5-bit ripple, let me take small n. Let me generalize the frequency formula. So for n-bit ripple counter, output is Fy. So Fy will be equal to, input is what for that n-bit ripple? It is F2. So F2 divided by 2 to the power n. So this is for n-bit ripple counter. This is how it looks like. So we have all the values. So F2 is this, substitute here. F1 is this, substitute here. So Fy is equal to 1 upon 2 to the power n into F2. F2 is F1 upon 2 into m, and F1 is F by n. Okay. Fy was 1000, 1 upon 2 to the power 5, है ना? Next, 1 upon 2 into 4, एक बार चेक कर लेने दो, 2 into 4, 4-bit Johnson counter, into supply frequency was 3.072, 3.072 into megahertz, so 10 to the power 6 divided by n. Alright, so we are having only one unknown, which is n. On solving this, we'll get n value as 12. N value as 12. So, if you are having mode n counter, means mode 12 counter, then your output frequency Fy will become 1000 Hz for the given frequency, which is 3.072 10 to the power 6 Hz. So, I hope you have liked the question and the solution as well. Please do not think in that manner, sir, the question is very lengthy, how I will be going to solve in the GATE exam. No, you will only going to get the portion of the question, not the overall. So, here please do learn the basics, the concept that we are discussing. Now, come to the chapter 6, which is the Q meter, and the important topic under this is measurement of self capacitance of the coil and measurement of self inductance of coil, and the third one is measurement of internal resistance of the coil. So, these are the important topics. Let us see the question. A Q meter is supplied with an oscillator having 100 millivolt input voltage. While testing an inductor, the voltage across Q voltmeter is obtained as 10 volt with resonating capacitance adjusted to 200 picofarad. The distributed capacitance of the coil is found to be 10 picofarad. The frequency of the resonance is 50 kilohertz. The Q factor and inductance of the coil is R. So, basically this is MSQ, multiple select question, where more than one options can be correct. Alright. Now, the Q is equal to Vc maximum, means maximum voltage across capacitor divided by input voltage. In the question, maximum voltage across capacitor is given as 10 volt. Okay, like say it is given na, Q voltmeter, means across the capacitor we are measuring this voltage, which is known as Q voltmeter, basically 10 volt. And what is the input? Input is 100 millivolt. So, ये कितना आ रहा है? 100 quality factor, which is given in option A. So, this is how you will going to obtain the quality factor. See, this is very simple, isn't it? You know, just you need to know the formula. If you are not knowing the formula, then you cannot be able to solve this question. Next, distributed capacitance means CD. Sorry, not CD, inductance L. This I need to determine. क्या होगा formula? याद है? L is equal to 1 upon omega square C plus CD. So, omega is the resonating frequency for the given capacitance. Okay. So, this frequency is taken for the capacitor C. Now, if you closely observe the question, resonating frequency is given as 50 kilohertz for the given capacitance, which is 10 picofarad, and distributed capacitance CD is given 200 picofarad. So, omega is 2 pi f 50 kilohertz, so 50 into 10 to the power 3. Resonating capacitance is 10 picofarad, so 10 into 10 to the power minus 12 plus distributed capacitance is 200 picofarad. Sorry, not the distributed. Okay, the resonating capacitance is 200 picofarad and distributed is 10. So, it is 200 into 10 to the power minus 12 plus 10 into 10 to the power minus 12. So, on solving this, you will get the answer as 48.25 millihenry, which is given in option C. So, A and C are the correct option for this question. So, guys, please do remember this formula Q wala and this inductance formula L. All right. So let us move on to the next problem, that is from the chapter 7, current transformer. And what are the important topics under this? Ratio error in CT and phase error in CT. So here comes the first question. Again, it is a multiple select question. More than one options can be correct. A CT has a bar primary rated at 500 by 5 ampere, 50 hertz with an output of 15 volt ampere. At rated load with non-inductive burden, the in-phase and quadrature component refer to the flux of the exciting MMF are 8 ampere and 10 ampere respectively. The number of turns in the secondary is 98 and the resistance and the leakage reactance of the secondary winding are 0.35 ohm and 0.30 ohm respectively. Then which of the following option are correct? So ratio error and phase error we need to find out. So let me note down the data. What data are given in the question? So bar primary, please do not think in another manner. So here the bar means primary turns as 1. Okay, bar means सरिया जो बोलते हैं ना, इस स्टील में जान है, something like that. So bar, if you see, it is a kind of one single line. So definitely it will not going to have any turn, na? So therefore it is 1. Next 500 by 5 ampere, 500 by 5 ampere. So this is primary winding rated current and this one secondary winding rated current. So the ratio of these two, look at here, the ratio of these two is known as nominal ratio, Kn. So 500 by 5 is equal to 100. Like we will going to use this Kn, na? And with the output of 15 volt ampere, means this is a load. Load is 15 volt ampere. At rated load with non-inductive, it means it is a resistive load. As load is non-inductive means it is resistive. The in-phase and quadrature component refer to the flux. So in phase, it means that the magnetizing current IM is equal to, कहाँ गया, 8 ampere and quadrature component IC, this is equal to 10 ampere. एक बार चेक कर लो. In phase means IM 8 ampere and quadrature 10 ampere respectively. Done. Next, the number of turns in the secondary winding. So number of turns in the secondary winding, let me write here NS, this is 98. And the resistance of the secondary winding means R2 is 0.35 ohm and X2 is 0.30 ohm. So my task is to calculate the ratio error and phase error. All right. So let us note down the formula first. Ratio error means percentage R. This is equal to Kn minus R whole divided by R into 100%. Where R is N plus IC cos del plus IM sin del divided by IS. Okay, just a second. So where del is, again where del is angle between ES and IS, means secondary voltage, secondary induced voltage and secondary current. Done. And N is the turns ratio. So let me write here N value. कहाँ लिख दे? चलो यहीं पे लिख दे रहा हूँ. N is the turns ratio, which is equal to secondary turns NS divided by primary turns. It is given in the question directly 98 and 1. So 98 by 1 is 98. This is turns ratio. Please please aware about the difference between the nominal ratio and the turns ratio. Turns ratio we will get from the turns of the winding, and nominal ratio we will get from the rated current of the current transformer. All right. So we have all the values. Next, like except del, we have all the values. Next, phase error, na? Phase error. So this is equal to 180 degree upon pi. So it is Im cos del minus Ic sin del whole divided by NIS. Whole divided by NIS. So this is the formula that we are going to use. Now let us find each thing one by one. Okay. So N we have obtained. Now del we need to find. So the current transformer is equivalent to your simple transformer. So primary winding and secondary winding. So since the secondary of the CT is similar to the secondary of the transformer, so let me draw only the secondary part. So the secondary of the transformer will have leakage resistance, leakage reactance, which is R2 and X2. Then you are having the load as RL, and since the load is non-inductive, let me not draw the XL part, because the load is non-inductive, means it is purely resistive. So it is your RL, and here this is your ES, plus minus ES, and here current is IS. Done. So please look at the approach very carefully. So ES by IS, this is equal to what? R2 plus RL plus JX2. So the angle of this is nothing but your impedance, overall impedance here. So angle of this is nothing but your del. वही तो लिखा था. So your del is nothing but tan inverse X2 upon R2 plus RL. So we have all the values except RL. So how we can get RL? Since the operation is under the loaded, then we can directly get the load resistance from this rated burden, which is 15 volt ampere. So 15 volt ampere is nothing but the current flowing in the circuit, which is IS square, and what is the load? Load is RL. So 15, IS is 5 because the load is rated, na? So this is rated value, primary side and secondary side. So 5 square into RL. तो ये वैल्यू कितना आ रहा है? RL, this is equal to 15 by 25 multiplied by 4, 60 by 100 means 0.6 ohm. So we have got the RL value. Substitute here. So this implies del is tan inverse X2 was 0.3 divided by R2 0.35 plus 0.6. So this is coming out to be as del value 17.525. 17.525 degree. Okay. So we have all the values. Substitute in the given formula. So R is equal to n, small n means 98 plus IW cos del, IW or IC. IC कितना था? 10. Cos del is 17.525 plus IM is 8 sin del, sin 17.525 divided by IS. IS was 5. Okay, IS was 5. So this is coming out to be as 100.38. 100.38. Now your percentage error or ratio error is equal to Kn, which was 100, minus R, 100.38 whole divided by 100.38 into 100%. So this is equal to minus 0.38%. Okay, minus 0.38%. So option B. Now come to the phase error. We have the formula for the phase error here. So phase error is equal to 180 degree upon pi into Im cos del, so 8 into cos 17.525 minus IW cos del or IC sin del 10 into sin 17.525 divided by NIS. So NIS value is what? Let me see. Small n was 98, IS was 5. यही लिखा था ना? NIS. Small n was 98, IS was 5. So from here we will getting the answer as 0.537. 0.537 degree. Any doubt in this question? So in which option it is given? Given in option C. So option B and option C are the correct option for this question. Got the concept? Please do remember all the terminology that I have written here, all the formulas that I have written over here, and this del value. So this del is what? Angle between this secondary induced voltage and secondary current. So from here you will get your del, and please remember this del is positive. Here the del is positive when the load is lagging or purely resistive. If the load is leading, means RC type of load, if the load is leading, then del value would have been negative sign. मान लो अगर वहाँ पे लीडिंग लोड होता तो आपको यहाँ पे डेल मिलता, so in the formula del has to be substituted with the negative sign for the leading load. So always be careful about the load. So let us move on to the next problem, the next chapter, which is the chapter 8, and this is the last chapter. So in this chapter we'll be having the two questions. So the first question comes at your screen like this. So let me give you 3 minutes to solve this question, not more than that. Your time starts now. Any answer? 1 minute remaining. Any answer? Guys, please do share the session link, as I am seeing very few views over here. So yeah, see, I have put in my 100% effort to frame such kind of question, to bring such kind of question in front of you. So in reward, I only want your support. And how you will going to support me? By sharing this session link with your friend and colleague. So please do inform that we are about to end the class. So before that, please do join, so that we will learn a lot of things from your side as well as from my side. So please do share the session link. Okay. 5 seconds remaining. Any answer? Any answer? Your time's up. The wiper of a 100 ohm potentiometer is positioned halfway as shown in the figure. The value of capacitor voltage at t equal to 5 seconds is. So this is your a potentiometer circuit, and this is one analog circuit, or you can say the non-inverting op-amp. Sorry, the inverting op-amp, not non-inverting op-amp, because here input is at positive terminal, na? So it is non-inverting op-amp. So when output becomes, at time t equal to 5, we need to identify, or we need to find the voltage across this capacitor. Any answer? All right. So what I will do, I will going to take this thing as a load, or I will going to consider this thing as a load. And after this, I will going to apply the Thevenin theorem, because I want this voltage. I want this voltage. Okay. So consider this to be a load, like this. This is your load. And then apply Thevenin theorem. Apply Thevenin theorem. So how we can do? How we can find the voltage and the resistance? Because Thevenin theorem is what? Remove the load, and across the load find the voltage, and across the load find the equivalent resistance. So it will look like this. Let me take this point as A, node A, and this point as node P. So since this is grounded, na, so your B is grounded. So therefore this ground and this ground is at B point, or at B node. So your Thevenin equivalent circuit will look like this. This is VTH, then this is RTH, and this is node A and node B, like this. Okay. After this, we will going to connect this thing. All right. So how we can find? So look at here. This is Thevenin equivalent, na? This is Thevenin equivalent circuit. Okay. So remove the load. So the circuit we will be having, let me solve here. Okay, just a second. Remove the load. So the circuit that we are having with look like this. 20 volt, just a second, 20 volt. And since this is position halfway, na, and total resistance is 100. So half means 50 ohm and 50 ohm. So it will be like this, 50 ohm, and here it will be 50. And this is node A and this is node B. This is node B and this is grounded. So we need to find VAB, which is Thevenin voltage. How we can find? 20 into 50 divided by sum. So here I have applied voltage division rule, which is equal to 10 volt. Now Thevenin resistance RAB, which is nothing but RTH. So this is equal to, how we can find? Deactivate all the independent sources. So here we are having only one source, which is voltage. So voltage source is going to be shorted, and the current source is going to be open circuit. So once you short this, then 50 and 50 will become in parallel. So overall you will get 25 ohm. 25 ohm. So this is nothing but your 10 volt and this is your 25. So when you fix this over here, your circuit will look like this. This is node A and this is node B. So this is 25 ohm and Thevenin voltage was 10 volt. And this is grounded like this. Any doubt? Clear? Now find the voltage at non-inverting terminal V plus. Let me write here this node voltage as V plus. So since the op-amp is ideal, so no current is going to be enter over here. So it will be 0 ampere. Similarly here it will be 0 ampere. So your V plus and V minus both are same because of the ideal op-amp. So let us find V plus first. V plus. So since no current is entering into the op-amp, whatever current is coming from the source, it will going to enter into this, like it will pass from 25 and enter into 25 again here, and it will complete its path. So therefore this circuit is in series, so we can directly apply the voltage division rule. So V plus is nothing but total voltage the total voltage is 10 volt into this voltage is V plus, this voltage. So their resistance is 25 divided by total sum of the resistance, which is 50. So this is equal to 5 volt. So we have got V plus as 5 volt. So similarly, from the concept of the ideal op-amp, your V plus is equal to V minus, which is again 5 volt. Now what is capacitor voltage? VC. VC is, see, this is 5 volt, na? So VC, see, the plus sign is at V minus and negative sign is at V naught. So can I write VC as V minus, means the voltage at inverting terminal minus output voltage, and V minus is 5 volt minus V naught is unknown. So my task is to calculate VC, or else if I have current through this capacitor, I can easily find the capacitor voltage by the capacitor voltage equation. All right. So what is that capacitor voltage equation? VC, we know that VC of t, this is equal to 1 upon C integration current through the capacitor into dt from minus infinity to t. So this can also be written as initial voltage across the capacitor plus 0 to t, plus 1 upon C integration 0 to t IC of t dt. All right. Now how I can find the capacitor voltage through that equation? Do we have any initial voltage over here? No. So therefore initial voltage of the capacitor is 0. Then what is the current which is passing through this capacitor? If you see, whatever current is coming from the output like this, it will flow here, and from the ground it will going to again return it. So my dear friend, if the current, whatever current is flowing in this resistance, the same current will flow through the capacitor as well, है कि नहीं? क्योंकि ये series में connected है. So can I able to find this current? Yes, I can find, because V minus is known to me. And what is that? It is 5 volt. So let me take, just a second, let me rub this. So let me take the capacitor voltage, the capacitor current is IC, or it is better to take in this direction IC, because the polarity has already been defined. Plus is at this plate, and we know that whenever the current is entering, that particular plate will be taken as a plus. So therefore, if the current direction is this, then the polarity will be justified. But here, what is the current direction? It will be opposite. Let me take here as IR. IR. Why? Why, sir? Because V minus is at higher potential, which is 5 volt, and this is grounded, and we know current will always flow from higher potential to the lower potential. So your IR, kahan gaya? Yeah, let me find here. Your IR will be equal to V minus voltage at inverting terminal minus ground divided by 1 mega ohm resistance. And what is V minus? It is 5 volts, so it will give you 5 microampere current. And this IR is nothing but minus of IC, or IC is minus IR, because both current are in opposite direction. So can I say this is equal to minus 5 microampere? Any doubt in this concept? Any doubt in this concept? No? All right. So from here, as initial voltage is 0, plus 1 upon capacitor is 1 microfarad. So 1 into 10 to the power minus 6, integration 0 to t. Current is minus 5 microampere, minus 5 into 10 to the power minus 6 times dt. So once you integrate this, we'll get the answer as minus 5t. Minus 5t. So such kind of thing, whenever the current flowing through the capacitor is DC, then it is said to be linear charging capacitor. Linear charging capacitor. Okay, so it will going to charge linearly till infinity. So for the DC voltage, your capacitor can reaches to infinity value. All right. So from here I can say that capacitor voltage Vc of t at t equal to 5 na, or 3 seconds, 5 seconds है क्या? Okay, at 5 seconds. At 5 seconds क्या होगा? Minus 5 into 5, this is equal to minus 25 volt. So if you are going to pick this option D, then you will going to have the negative mark. Why, sir? Let us discuss the point. See, as I told you, your capacitor Vc is V minus of V naught, है ना? यही लिखा था ना? V minus of V naught, which is Vc. Vc is minus 25. V minus was 5 minus V naught. So from here V naught value is 30 volt, which is not at all possible. If you are having the capacitor voltage as minus 25, then your output voltage becomes 30 volt, which is impossible, because you have fixed the output voltage as plus 20 volt and minus 20 volt, which is the maximum voltage. The op-amp voltage cannot exceed this voltages, which is a basics of your analog, na? or of op-amp. So therefore this answer is going to be wrong, or else this capacitor voltage is going to be wrong at t equal to 5 seconds. Because if it is going to show your output becomes 30 volt, which is not at all possible. Then what is the correct solution? Let me rub this, it is not required. So I hope you have got the concept, na? Then what is the correct answer? So let me write a point here. At VC T equal to minus 25 volt, output reaches to plus 30 volt, which is not possible as saturation voltages are plus minus 20 volt. So how to find? Then how to find the solution? See, as soon as your capacitor is going to charge, kahan gaya? With this equation, your capacitor is going to be charged, and for that capacitor voltage where output reaches to 20 volt, for the capacitor voltage where output reaches to 20 volt, then that capacitor voltage is going to be fixed. It cannot be increased linearly because the output is going to fixed at plus 20 volt. समझ में आया मेरे कहने का मतलब? ये कैपेसिटर क्या करेगा? इस आउटपुट को इंक्रीज करते रहेगा धीरे धीरे करके. नाउ जहां पर भी आउटपुट 20 वोल्ट हो गया, इस कैपेसिटर का भी जो भी वोल्टेज होगा, तो वो कैपेसिटर वोल्टेज जो है अब फिक्स रहेगा टिल द टाइम t इक्वल टू इंफिनिटी. तो मुझे वो फाइंड करना है कि वो क्या टाइम है या वो क्या वोल्टेज है such that my output is going to fix to the saturation level. Now since it is a non-inverting op amp and input is positive, therefore your output is also going to be positive. Remember, your input is positive. Due to this non-inverting op amp, your output is also going to be the same sign, which is positive. And what is the voltage then we are going to take? Plus 20 volt. So Vc of t, which is equal to V minus of V naught. So we need to find this capacitor voltage Vc of t. V minus was 5 volt, which is fixed, minus V naught is 20, so it will be minus 15 volt. Done. Now we know the relation minus 5t, like this equation, minus 5t. So this is equal to minus 15 volt. So at time t equal to 3 second itself, your capacitor or your output reaches to plus 20 volt. So let me draw the waveform so that we can understand this question very carefully. The first axis is of capacitor voltage and the next is of your output voltage. Anyway, we have got the answer, that is 15 volt. So at this particular time, your like at t equal to 3 second itself, your output is capacitor voltage is going to be fixed because your output reaches to maximum value. So after this means the t greater than equal to 3 second, your output is going to be 15 volt till the infinity. Okay, so look at here. So initially your So initially your capacitor will have a 0 voltage because it is uncharged. So therefore it will start from 0 volt and it will charge linearly till minus 15 volt. है कि नहीं? At t equal to 3 second, it reaches to minus 15 volt. What about output? As capacitor is discharged, your output, as capacitor is uncharged, so initially this is 0. So output will be V minus, which is 5 volt. So this is your 5 volt axis. After this, the capacitor is going to charge, and therefore your output voltage is going to increase like this. So at t equal to 3 seconds, your output becomes 20 volt, and after this your output voltage is fixed. Till infinity. What it means? What it implies? It implies that your capacitor voltage is also fixed. So if you observe carefully this curve, at this point is t equal to 3 seconds. So let us take this is t equal to 5 seconds. So at t equal to 5 seconds itself, your capacitor voltage remains minus 15 volt. So either you can go by this conventional approach or you can go by this waveform method. So the correct answer for this question is minus 15 volt, which is given in option D. Option D. So I hope you have got the concept. Here always remember, whenever you are having the current through the capacitor as DC quantity, then it will charge the capacitor to till infinity if there is no restriction of the saturation voltage. Okay, and such kind of thing is known as linear charging and discharging of the capacitor. This is evident from here itself, from the capacitor equation. See, the capacitor is charging linearly, minus 5t, or from the waveform itself, charging linearly. अगर यहाँ पे saturation नहीं होता ना, तो ये इस direction में increase होते रहता. If there is no saturation voltages, then the capacitor would have been charged in this direction. All right. So let us come to the last question, and this question is a combination of your signal system, of your analog, of your measurement, of your network. So this question is basically a combination of the 4 subjects, or the concept of the 4 subjects. So let me give you a 3-minute time for this. Your time starts now. Do it fast. 1.5 minutes remaining. If you need more time, please do let me know. All right, time's up. Now look at the solution. The equivalent circuit of a diode during the forward bias and reverse bias condition are shown in figure 1. If such a diode is used in the circuit shown in the figure 2, this is figure 2, then the output voltage waveform observed on the oscilloscope will be: assume CRO operation mode as YT mode and deflection sensitivity Sx equal to 0.6 division per millisecond and Sy equal to 0.8 division per volt. All right, done. So we need to identify what should be the output waveform which we are going to observe on the CRO. Now if you see carefully, this is a voltage source, this is your diode, and in parallel to the diode and 5 volt you are having the 10 kilo ohm resistance, and in that 1 upon pi t function is connected, or basically this is a this is one kind of equivalent circuit you can say, which is all together going to give you the output V naught. Now please do let me know where you have seen this 1 upon pi t, in which subject or in which chapter you have seen 1 upon pi t function, and I am 100% sure that you are knowing about this. All right. Now before that we need to see whether the diode is on or off, because all the operation depends on the diode condition. And please remember, this is a thumb rule. Whenever you are having the diode or general diode, then always identify the region of operation of the diode. Okay. All right. So let us assume diode is off. Diode is off. What it means? Diode will be open circuit as it is in reversed bias region. So here it is open circuit. So let me write voltage here as Vd plus minus Vd. Done. All right. Now this, let me take here output voltage, like the fictitious output voltage as V naught 1. V naught 1. So can I say your Vd or V naught 1? Your V naught 1 is equal to diode voltage Vd plus 5 volt. है कि नहीं? Plus 5 volt. So from here what is diode voltage? Vd, V naught 1 minus 5 volt. So let us find V naught 1. Since no current will flow in this branch due to open circuit that we have assumed, then V naught 1 we can directly find by using voltage division rule. So V naught 1 is what? 10 sine 314t into 10k divided by sum. I think there is some correction. Okay, just a second. Okay, extremely sorry, this is 10 kilo ohm. This is 10 kilo ohm. This is 10 kilo ohm. Okay. So 10k divided by sum, which is 20k. So from here we'll get 5 sine 314t. Now your Vd is 5 sine 314t minus 5 volt. Now look at this expression very carefully. The diode is going to be open or short circuit, or it will going to operate in forward bias region if diode voltage is positive, and if the diode voltage is negative, then it works in reverse bias region or it behaves as an open circuit. Now can anybody please let me know that for any value of your sine, whether Vd will going to be positive, exclude 0 volt, whether Vd is going to be positive for any value of sine? No, it will not going to be positive, because what is maximum value of sine? +1. What is the minimum value of sine in the negative direction? -1. So for +1, or Vd will be 0 volt for sine of +1, है कि नहीं? And Vd will be -10 volt if sine 314t is -1, because maximum value क्या होगा sine का? From +1 to -1, इससे बाहर तो नहीं हो सकता. So I have taken all the values. So therefore your diode voltage is oscillates between 0 volt to -10 volt. It implies that your diode voltage is always negative. So since it is always negative, therefore it will never going to be on, or it will never going to be open circuit. It will always remains in off region or reverse bias region. Hence our assumption is correct. So we have obtained the V01 value, which is 5 sin omega t. V01 expression as 5 sin omega t, which is correct. Okay. So V01 is 5 sin omega t, which is the voltage across this 10 kilo ohm. Now this voltage V01, let me write here. Okay. Just a second. Okay, so this is V01. This is 1 upon pi t, and output is V0 of t. This is what your equivalent circuit will look like after we identify the operation of this diode. Now if you see, this is what a non-periodic signal, and for non-periodic signal, how we can find the output? By using the Fourier transform. Fourier series is applicable for the periodic waveform, whereas the Fourier transform is applicable for the non-periodic waveform. So how we can find the output? V0 of t is equal to convolution of input V01 of t, this is convolution symbol, into 1 upon pi t. Basically I need to write Fourier transform. Just a second, I need to write the Fourier transform, it will be good. So Fourier transform of V0 of t, which is nothing but Fourier transform of convolution of V01 of t and 1 upon pi t. So this is written as Fourier transform of V01 of t convolution of Fourier transform of 1 upon pi t. Okay. So convolution in time domain, like convolution is used in time domain. So here convolution means summation of these two individual quantity, summation, and this thing is equivalent to the multiplication in the frequency domain. So अगर आप इसको frequency में कर दोगे तो ये summation जो है और summation जो है वो convert हो जाता है multiplication में. So V01 j ओमेगा इंटू इसको ले लेते हैं, क्या ले लिया जाए इसको, h of j omega. Let us take this as h of t. This is h of t, and your output will be V naught of j omega. So I hope this is clear to you. Addition or convolution in time domain is equal to multiplication in the frequency domain, where omega is a frequency. So let us solve one by one. Let me take V naught 1 j omega. So for that, let me change the color. Sorry. V naught 1 j omega. So this is Fourier transform. This is Fourier transform of, ये कितना था, 5 sin, कहाँ गया, या V naught 1 is this value, 5 sin 314. So let me take 5 sin omega ct, where omega c is 314. Please look at the solution very carefully, because this question is full of the concept, full of the tricks. All right. Now what is the Fourier transform of this 5 sin omega ct? Fourier transform, see, 5. Can I write this sin omega ct as e to the power plus j omega ct minus e to the power minus j omega ct whole divided by 2j? है कि नहीं? We can write like this. So this is equal to 5 upon 2j. We can take out the constant term outside of the Fourier transform. It will not affect the Fourier transform. All right. So we are left with this part. So Fourier transform of e to the power j omega ct minus Fourier transform of e to the power minus j omega ct. All right. Now Fourier transform of e to the power j omega ct, ये क्या होगा, कितना होता है? It will be 2 pi del omega minus omega c. If it is plus here, here will be having the minus sign. And Fourier transform of e to the power minus j omega ct, then you will be having 2 pi del omega plus omega c. So let me inbox these two formula. All right, so this will be equal to 5 by 2j into इसका Fourier transform 2 pi del omega minus omega c minus 2 pi del omega plus omega c. Okay. So कुछ cancel हो रहा है क्या, या 2 is going to be cancelled out. So we are left with 5 pi by j del omega minus omega c minus del omega plus omega c. Done. Or let me write here, or this can be equal to, like this can also be written like this, 5 pi by j del omega minus omega c minus 5 pi by j del omega plus omega c. Any doubt till this point, please do let me know. Any doubt till this point, please do let me know. ठीक है. Now in the frequency spectrum, this can be observed like this. Okay, so this is V naught 1 j omega. All right. Now since this is a del, and del is only applicable, like the del will be given the value at only one particular instant. Equate the inner term to be 0. Only at that particular instant you will be having this value. Okay. So this is V naught 1 j omega, and this axis is omega. So at omega equal to omega c, which is positive, omega c is what? Positive value, na, 314. So at omega equal to omega c, this side is omega positive and this side is omega negative. So at omega equal to omega c, you will be having 5 pi by j. So the strength here is, let me write, sorry, and here so this value at omega c, which is 5 pi by j, and at equate it to 0, omega plus omega c means omega equal to minus c. At omega equal to minus omega c, what is the strength? Minus 5 pi by j. This is your frequency spectrum. Done. Now let us solve the second part, which is Fourier transform of 1 upon pi t, which is h of j omega. So h of j omega is Fourier transform of 1 upon pi t. Now for this we will be using the duality principle. Like here, the formula that we had discussed, na, this is the this is basically what? Duality principle. The Fourier transform for a function for which we cannot find the for which we cannot able to find the Fourier transform easily, then for such kind of function we will be using the duality principle. Okay. I am not going to enter into much detail, otherwise it seems to be a signal system class, so do not worry about that. Let me discuss only what is duality principle. For that, let me change the color. Okay. Suppose you are having some function, let me take x of t. You are having any function x of t, and for that you are having Fourier transform as x of omega or x of j omega, both are same. Then for such function, for such time domain function for which we cannot apply the Fourier transform easily, then we can use duality principle. Then Fourier transform x, like see x, whatever function you are getting here, which is in omega, replace that omega with time. Then here you will be getting 2 pi small x, and here replace t with minus omega. समझ में आएगा? पहले इसको फाइंड कर लो, देन अगर आपको इसका लैपलास ट्रांसफॉर्म फाइंड करना है तो कैसे करेंगे? यहाँ पे जो भी ओमेगा होगा रिप्लेस विथ टाइम, और यहाँ पे जो भी टाइम है उसको रिप्लेस करो माइनस ओमेगा से along with 2 pi as its strength, or else this can also be equal to, or this can also be equal to x of minus f. This is in omega, this is in f, both are same. All right, so this is a duality principle. Okay, so let us find. Uh, First, let us see for which kind of time function we are having this kind of Fourier transform, like in which we are going to get the Fourier transform. So for the signum function, which is u of t minus u of minus t, or this can also be written as 2u of t minus 1. I am trying to find the transfer function for such signal which is going to give me 1 upon pi omega. So when I replace with like omega with t, I can easily apply the duality principle. तो मैं पहले फाइंड करना हूँ 1 अपॉन पाई ओमेगा कहीं से मिल जाए, फिर उसके बाद ओमेगा को मैं t से रिप्लेस कर दूंगा by using duality principle. All right, so let us take this as x of t, this as x of t. Now differentiate this d by dt of x of t. क्या मिलेगा? 2 times of derivative of u of t is del of t minus इसका derivative 0. So take the Fourier transform, will get j omega x of j omega or x of omega, both are same, which is equal to 2 into what is Fourier transform of del of t? It is 1. This is equal to 2. So from here x of j omega will be equal to 2 upon j omega. Okay. Now apply duality principle over here. So replace omega with t. So let me change the color. Apply duality principle. See, 2 by, just a second, let me change the color. 2 by jt, replace omega with t. Then its Fourier transform will be 2 pi, like you have replaced omega with t, na? So you will need to use this formula 2 pi. This is your x of t. Wherever you are having t, replace with minus omega. So it will be signum of minus omega. But still we have not obtained 1 upon pi t. Now how we are going to get? Look at here. 2 jt, its Fourier transform is minus 2 pi signum of omega. Means what I had did, signum of minus omega can be written as minus signum omega because this signum is an odd function. Odd function में क्या होता है? f of minus t is equal to minus f of t. F of minus t is equal to minus f of t. This is what I have written. Signum of minus omega equal to minus signum omega. Now since the Fourier transform is a linear, then we can cancel 2 and 2 and take this j there and pi here. We'll get 1 upon pi t because of the linearity principle. हाँ, क्या मिलेगा? 2 will be cancelled out and take pi here and take j here. We'll get minus j signum of omega. Minus j signum of omega. All right. So let me draw its frequency response. Okay. So this is 1 upon pi t ना, तो इसको क्या लिखा था हमने? Fourier transform. Let me change the color. So this was h of j omega and here it is omega. Now for omega greater than 0, what is the strength or what is the value? Minus j. So sorry, it will be minus j, na? So it will be here. Done. So this is for omega, okay, extremely sorry, minus j की बात at omega greater than 0. Okay, all right. So we need to delete this minus j. Okay, so this is minus j where it is valid for omega greater than 0. And in the same manner for omega less than 0, for omega less than 0, it will be plus j. क्या ये समझ में आया? नहीं आया? चलो ठीक है, मैं थोड़ा सा और इसको अच्छे से बता देता हूँ, so that we can understand it in a more clear manner. I know for some of the aspirant it is going above our head, so for that let me discuss this particular thing in detail. So minus j signum of omega, this can be written as minus j u of omega minus u of minus omega, जैसा यहाँ पे लिखा था, signum of t equal to u of t minus u of minus t. So this is minus j, signum of omega is u of omega minus u of minus omega. So this is equal to minus j u of omega minus minus plus, so plus j u of minus omega. So minus j will come for omega greater than 0 and plus j will come for omega less than 0. So omega less than 0 means this side. So this is at omega less than 0. So let me write omega less than 0 here. Why I am doing this? Because I need to write omega c. So for that I require some space. So omega c will be somewhere here. है कि नहीं? Similarly, minus omega c will be somewhere here. At omega c, what is the strength? Minus j. At minus omega c, what is the strength? Plus j. वहाँ से देख लो. Plus j. Done. All right. Now, if you look at the two frequency spectrum very carefully, to obtain V naught j omega, this value, to obtain V naught of j omega, I require multiplication of the two individual Fourier transform. Now, accept minus omega, accept plus j omega, sorry, accept minus omega c and accept plus omega c, accept minus omega c, accept plus plus omega c, other values are 0. है कि नहीं? सिर्फ माइनस ओमेगा सी में माइनस 5 पाई बाई जे एंड प्लस ओमेगा सी में प्लस 5 पाई बाई जे, बाकी जगह पे क्या है? वी नॉट 1 की वैल्यू 0. सो व्हेन यू मल्टीप्लाई दिस with this, what you are going to get? Let me draw it here. Because we are doing the frequency multiplication, na? So only at omega c and minus omega c will be having a value. So क्या वैल्यू मिलेगा यहाँ पे? जस्ट अ सेकेंड, क्या वैल्यू मिलेगा? दिस इज वी नॉट ऑफ जे ओमेगा ना, वी नॉट, ओके, दिस इज वी नॉट ऑफ जे ओमेगा मीन्स द आउटपुट एंड दिस इज ओमेगा, वी नॉट ऑफ जे ओमेगा एक्सिस एंड दिस इज ओमेगा एक्सिस. सो एट ओमेगा सी let me write here omega c and let me write here minus omega c. चलो देखते हैं क्या मिल रहा है. So at omega c it is minus j and here it is 5 pi by j. So multiply both the strength, 5 pi by j into minus j, it will be minus 5 pi. So minus 5 pi means in downward direction. Means it is minus 5 pi. Next means at all the others frequency it will be 0 because V naught 1 j omega here and here all are 0. So when you multiply the remaining frequencies strength it will be 0 except this omega c. Similarly at minus omega c ये कितना है plus j और यहाँ कितना है minus 5 pi by j. So it will give you minus 5 pi again. Will give us minus 5 pi again. So from here I can write, from here I can write V naught j omega, V naught j omega is equal to minus 5 pi at only at one place. So it is del omega plus omega c. Again here plus minus 5 pi for this del omega minus omega c. So what is Fourier transform? What is Fourier transform? We cannot find easily because we need to multiply it with 2 and divide it by 2. So 2 pi del omega plus omega c plus minus minus 5 plus 2 pi del omega minus omega c. So I have multiplied and divided by 2. Now once you take the Fourier transform inverse in V naught of j omega, will get V naught of t, V naught of t. So here I am taking Fourier transform inverse. So minus 5. So इसका Fourier transform क्या होता है? इसका Fourier transform cos omega ct. So ये Fourier इसका Fourier transform inverse. So what is the Fourier transform inverse of this? It will be cos omega ct and omega ct is 314. All right. So we have got V naught t as minus 5 cos omega ct. Now this has to be observed on the CRO. How it is going to be observed? The unknown signal waveform is observed only in YT mode. In YT mode, unknown signal is applied on Y plate and known signal is applied on here. Known signal is applied in X plate. Okay. So just a second. Since I am not having space over there, so I am writing in this section. Okay. So look at here. At X plate, we will be applying the sweep signal or which is known as ramp signal, and unknown signal will apply here at Y plate. So at Y plate, let me write here. At Y plate, we will be applying, this is, let me write here T, this is Vy of T, which is nothing but in this case V naught of T. And what is this signal? This signal is minus cos omega ct. Means minus 5 cos omega ct. So this value is minus 5 and this value is plus 5. Done. And each half or this thing Okay, so this is let me take t equal to 0, t1, t2, t3 and t4. This is applied on y plate, and on x plate we need to apply the ramp signal, which is a reference signal, and this is supplied by me or applied by me. So this is a sweep signal. Just a second, let me take the reference. So this is Vx of t, and this is time t. Okay, so this is applied by me. So let me take here voltage as minus 5 volt, the same voltage, and here voltage as plus 5 volt, plus 5 volt. And this time is T1, this time is T2, this time is T3, and this time is T4. Now this has to be drawn on this CRO. Now if you see carefully, this is a screen of the CRO, and this dash line are gratitudes. So if you see, this is your center origin. This can be treated as a first half or the first quadrant, second quadrant, third quadrant, and this fourth quadrant. So in the first quadrant, x and y both are positive. In second quadrant, x is negative, y is positive. In third, both negative, and in fourth, y negative, x positive. So this thing is going to be plotted by the CRO. So look at into the question, the sensitivity is given. So which is 0.6 division per volt, it has to be per volt. So anyway, it is directly given as millisecond, but anyway it has to be volt. And SYS 0.8 division per volt, it has to be volt. So I think it is given, no? All right. So let me check, just a second, let me check. Okay, क्या करें यहाँ पे 4 division 2.5 2 division. Okay, let me take 0.8 division per volt and SYS 0.8 division per volt. Anyway, both will not going to affect your answer. Your answer will be same. Only there will be a difference in the length or the span of the curve. So SX is 0.8 division per volt and SY is 0.8 division per volt. Means here in the CRO screen, for 1 volt it occupy 0.8 division. Okay. So my dear friend, let me make the curve here, sorry, let me make a table here which will help us to draw the curve. Just a second, we are about to complete. So this is Vx of t and this is Vy of t. Okay. Okay, at t naught, or let me take here this as t naught, this point is also be t naught. Now since the sensitivity of Sx and Sy both are 0.8 division per volt, 0.8 division per volt, then at minus 5 volt, which is at Vx and Vy is at minus 5 volt. So for 1 volt it is taking 0.8 division, then for minus 5 volt, how many division? It will be minus 4. It will be minus 4 division. So minus 4 division, minus 4 division. समझ में आ गया? So this is how the sensitivity is defined. On the basis of this, the plots are going to be happen on the CRO screen. So for 5 volt it will be like for minus 5 volt it will be minus 4 division. Minus means it will be on left hand side for X and it is at the bottom for the Y, because both are same. Similarly at T1 this is minus 2.5. This is minus 2.5 volt and here it is 0 है कि नहीं, यहाँ 0. तो for minus 2.5 what is Vx? Vx is minus 2 division. So minus 2 division Vx, please check it. And for Vy it is 0 division. Similarly at T2 it is 0 and it is maximum, which is plus 5. So Vy is plus 4 division and it is 0, so 0 division. Similarly at T3 it is 2.5 plus 2.5. So Vx is positive now. Vx is positive, so it is plus 2 division. है कि नहीं? Multiply with 2.5 on both sides, we'll get 2. And next Vy at T3 it is 0 division. It is 0 division. Next at T4 we are having plus 5 volt, 2.5, all the values. So let me take only one value, which is plus 5 volt, and here it is minus 5. So Vx is positive, so plus 4 division because of plus 5 volt, and Vy is negative, minus 5, so it is minus 4 division. So my dear friend, your Vx is varying from plus 5 volt to minus 5 volt in 0 second, क्योंकि ये T4 पे पूरी वैल्यू है Vx की. So therefore it is varying from plus 5 division to minus 5 division, whereas Vy remains same. मेरे कहने का मतलब जब ये चेंज हो रहा होगा from plus 5 volt to minus 5 volt Vx की वैल्यू, so it will be plus 2.5 division, it will be same. Similarly for 0 division it will be again same, minus 4 division, and let me take the last one, which is minus 5 division, and here it will be minus 4 division. So your x is changing, whereas your y remains same. At T4 second पे value देख लो ना, at T4 second पे. Done. Now let us plot this thing. अब मजा आएगा यहाँ पे देखने में. Okay. So look at here at T naught minus 4 division, minus 4 division. कहने का मतलब Vx is negative and Vy is negative. So negative means x is on left hand side. So this is 1 division, 2 division, 3 division, 4 division. And Vy minus 4 division means 1 division, 2 division, 3 division and 4 division. So this is T naught वाला point. ठीक है, देख लो एक बार. 1, 2, 3 and 4. 1, 2, 3 and 4. नेक्स्ट माइनस 2 डिविजन 0 डिविजन, तो कहाँ पे होगा? Vy इज 0 डिविजन मीन्स इट विल बी हियर, इट इज T1 वाला पॉइंट. नेक्स्ट 0 डिविजन प्लस 4 डिविजन, सो 0 डिविजन फॉर x 1, 2, 3, 4, सो इट विल बी T2. T naught, T1, T2, then T3. Vx is plus 2 division, 1, 2, and it is 0 division over here. So this is T3. Then at T4 plus 4 division minus 4 division. So Vx is plus 4. 1, 2, 3, 4 and minus 4. 1, 2, 3, 4. And from minus 4 it will come again to this point. So this is T4 na. So the transition is so fast from here to here, it cannot be visible to the human eye. The transition is at 0 seconds, so it cannot be visible by the human eye. Okay, so here I have taken only 5 points. Basically we need to take infinite points. See, here I have taken only 5 points. T0, T1, T2, T3, T4. हमें पूरे points लेना है from T0 to T4. ये point भी लेना है, ये point, हर एक point लेना है यहाँ पे. to get the accurate waveform. So let us join all the point. Let us join all the point. So from T0 to T1, just a second. Then T1 to T2, then T2 to T3, then T3 to T4, like this. And after this transition is from here to here, like this. But this transition is so fast, or this transition is at 0 second, which cannot be visible to by our eye, like which cannot be visible to our eye. So पहले ये complete होगा, again it will going to repeat like this, again it will going to repeat like this. So in the CRO screen you will going to see this kind of figure. All right, so in which option it is given? It is given in option D. Option D. So option D is the correct option for this question. So I know there was some mistake, there was some typing mistake in the question, but anyway, once this question is going to be uploaded, basically once this video is going to be once the session is going to be over, the PDF of this thing, the corrected question will be shared over the Telegram group. So from there you can practice. Okay, all right. So with this we have completed all the syllabus of the measurement through some selected question, some difficult question, and some conceptual question, and very, very, very interesting question, isn't it? So with this we have completed all the part of the measurement for EE and IN. So in your free time, please do watch the session again and again. Definitely you will going to master in the measurement. As I know that most of the students were thinking that sir question तो बहुत easy आते हैं measurement में, तो क्यों ही पढ़ना? See, anyone can from any question from the measurement by combining the concept related to the different subject. All right. So let me take a few minutes of you. This is our live online program features for GATE 25 and 26, where we are giving 800 plus hours of live classes with live interaction with the faculty, theory book, exercise book, and 30 plus years of GATE question bank along with the video solution. So we are providing exercise book where the questions are categorized as level 1, level 2, level 3. Level 1 is easy, level 2 is moderate, level 3 is very difficult. And 30 plus year of GATE question bank along with the video solution, which is very, very important. And 12 personalized one-to-one mentorship session means here the students are going to get a chance to interact with the faculty, and whatever general doubt they are having, technical, non-technical, they can ask to the to our expert faculty, and our expert faculty definitely going to help in a best possible manner. All right, and we are having 130 plus online test with video solution of mock test and many more. So if you want to counsel yourself, then you can book a free counseling by calling on this number. So these two number, like in any of these two number, you can call and our expert team will going to help you out, or else you can directly click on the link which is given in the description box, and our team again will going to help you out. Okay, and this is our online class interface. So once you're going to enroll into the online live program, now you will going to get such kind of interface where we will be dealing in a digital board. Okay, so this is a one you can say the image that we have have here, that we are having here, and this kind of image you can experience in the live class. All right. And as I told you, the PDF of this session, not only of this session, all the session that we are conducting over the YouTube, you will going to get in the at the Telegram, and the link of the Telegram is given in the description box, or else you can visit to this ID. And what you are going to get? Lectures PDF, as I told you, schedule of the free YouTube lecture, important update related to the webinar and seminar, PSUs and other government job notification, expert session on important topic, and daily quiz and many more. So these daily quiz are very, very important, and it is benefiting to the student or the GATE or to the GATE aspirant, those who are already a part of our Telegram channel. So please do join on the priority basis to get the maximum from IMS GATE Academy. All right. So with this, let me end the session, and one request, please guys, do hit the like button. Please share the session link with your friend, and even if you have not yet subscribed to our YouTube channel, please do subscribe. It is very important, because we are again coming up live with more initiative. Okay, so for that you need to subscribe and also press the bell icon to get instantly notified. All right, so all the very best for your GATE exam and your future and the future. Please, whatever doubt you are having, once this session is going to be ended, please feel free to post in the comment. Whenever I'll have a time, I will going to rectify all the doubts. Bye bye, and take a very good care of your health.